Alright, Kerbal Knots, welcome back. So this week's episode, we're going to be going to the moon. So hopefully if you're in career mode, you've already upgraded your tracking station, because you're definitely going to want to have done that in order to pull off some of these maneuvers. So here I am out in space. This is a very similar rocket to the last one that I got into orbit. You'll notice there's two of the 400 size fuel tanks. I've got the Science Junior module on here. I've got the command pod. And we should be good to go for a little flyby of the moon with Jebediah here. Alright, so we need to understand a few things about orbital mechanics, but don't worry, it's not as hard as it sounds. The first thing is knowing what happens when you burn prograde or retrograde while you're in orbit. So if I plan a little maneuver right here, if I add a little maneuver point, it's basically giving me like a little computer guidance here. It's saying, okay, if you do a maneuver here and I change my speed by this much, so if I add 149 meters per second to my speed right here, the yellow dotted line that shows up will be my new orbit for my spaceship. Notice that changing my speed down here changes my orbit on the other side. I don't really change the height of my orbit down here. But it does move the orbit on the other side, and depending on where I go, like if I move that maneuver point to somewhere else along my orbit, it's always going to affect the opposite side. So a pretty important thing to remember when you're trying to figure out how do you want to go somewhere. All right. The next thing we want to do is let's go ahead and close that. Oh, well, before we close that, we'll go ahead and talk about... Well, I'll do that here in just a second. Okay, so if you speed up, you're going to affect your orbit on the opposite side. If you slow down, you'll also affect your orbit on the opposite side, but obviously you will lower your orbit instead of raising it. And those are the two little two maneuvers that we need to worry about for this mission right here in particular. So I've got a good little equatorial orbit going here, very low inclination. I want to set the Mun as my target because I'm trying to intercept with the moon. The moon, whatever. And I want to go for what we call a free return trajectory. I'm just going to do a quick flyby of the moon. And so after I fly by the moon, I want to be recaptured by Kerbin's gravity so that I come back into orbit around the planet. Now I've got about 174 units of fuel left. That should be enough to get me out to the moon and then get me back. But that's something to definitely be aware of if you didn't have a good flight on your way up to get into orbit. You might run out of fuel. Also, something to keep in mind too is that electric charge is a very valuable resource that you want to manage as best you can. So one of the ways to manage that is by turning off the SAS like I just did. If you keep the SAS turned on, anytime you do a little maneuver like I did just there, you're using up electricity. So it's something to keep in mind. Okay. So to get to the moon, you've got to have it at about 3 o'clock, and it's going to be different for every body that we go to. You'll notice there's another body out here called Minmus. Getting to Minmus, you'd need to line it up in a different orientation, but that's a future episode. For getting to the Mun, we want it to be at about 3 o'clock, and then our maneuver node that we're going to plan is going to be down here at about what we would call 6 o'clock, if these were clocks that we were looking at. So now that I've got my maneuver node picked, I want to burn prograde there so that I raise my orbit, and I'm going to be extending that orbit outwards towards where the moon is going to be eventually. Right? So notice how that orbit is growing. You can also use, if you have a wheel on your mouse, you can use the wheel. So notice right there, I'm almost out intersecting with the moon's orbit, and I'm a little bit ahead of the moon, and that's fine. So I'm actually going to be going out a little bit past the moon, and then coming back in, and I'm going to have the moon periapsis there of about 252,000. Let's see if we can get a little bit better than that. 348. Whoops. 348. Let's go a little bit more. See what that is. 269. And see, if you'll notice my delta V requirement here, this green number is showing me how much I need to change my speed by. You'll notice there's not a whole lot of difference in the delta V requirement for even this much maneuver here. It's like 1/10 of a meter per second is making a huge difference on this maneuver. So something else to keep in mind. So you have to be very careful about not overshooting your target here. All right, so that looks like it's going to get me a good encounter there with the Mun. I'm going to be at about 218,000 meters above it. I'm going to be captured by the gravity momentarily. As I fly by, I'll be able to get some science points. I'll complete a contract, and I'll be getting some good money there. So in order to get this maneuver, you'll notice a couple things have popped up on the nav ball now. You'll see this little blue arrow down at the bottom of the nav ball, because that's where I need to actually point my ship in order to execute this maneuver. So I'm going to go ahead and point the ship in that direction. Right, so that's where I'm going right now, which seems a bit odd in the placement. That's because I'm on the opposite side of the planet now. When I come back around the other side of the planet, everything will be lined up perfectly, and I'll actually be burning prograde. That blue mark will line up with this, well, not that one. The other one would be the retrograde mark. And also this blue mark would be right on the horizon, right on the border between the blue and the brown once I'm lined up there. So I want my marker to stay there. Turn on SAS. Well, if I keep SAS on, I'm going to be using up electric charge. So what I'm going to do is just time warp ahead about 9 minutes or so, or maybe 8 minutes, and just drift around to the other side of the planet. And I'll realign my spaceship once I get there, because I don't want to waste electric charge by trying to hold that position. Alright, so there we go. 2 minutes away from the node, so now I will get pointed in the right direction. I'll get my little indicator right on that blue marker on the nav ball. One of the things to do to try to get more precise maneuvering is to turn on caps lock while you're doing these maneuvers out in space, because then your controls are much more sensitive and you won't always be overshooting your targets. So right about there, I'll turn on the SAS. I've got 1 minute and 3 seconds total burn time, and you always want to spread out your burns evenly on each side of your node. So I'm going to be starting my burn about 30 seconds before the node and ending it about 30 seconds after the node. And that way you get the best kind of approximation of, to really get that orbit, you need to change your delta V, you need to change your velocity instantly by 866 meters per second. But since that's kind of impossible to do, we have to spread it out, especially since we got this weak little engine on here that's more fuel efficient. So we're getting closer here, about 20 seconds or so before I need to start my burn. I want to start it with about 31.5 seconds before the node. So I'm about 10 seconds away now. I'm just going to go full throttle, so I'm just going to hit the Z key as soon as it gets down to about 31.5 seconds left. And there we go. And you can see my apoapsis growing. It's going to extend out there towards the Mun's orbit to try to get that encounter with the Mun. You'll see there's other bodies out there too. There's Jilly, which is a moon on a different planet called Eve, orbiting around a different planet. You can get a good look at the whole system here. Lots of planets out there, but don't want to get carried away looking at that so that I don't completely overshoot my orbit. So as this maneuver is taking place, I'm kind of readjusting my nav ball here because that maneuver node shifts just a little bit as you're is trying to compensate for any kind of overshooting you may be doing, or maybe you're off a little bit on the dial. And about 200 meters per second to go. And once I get close, I'm gonna go way back down on the throttle. And I'm gonna use the shift key to throttle up slowly. And there's my encounter. Oh, okay. Got a little much there. Got a little bit too much. I'm gonna just go ahead and point the opposite direction. Overshot my target just a little. So I'm gonna go and burn retrograde. There we go. That should be good. Okay. So now you can see this blue line is where I'm gonna be going. I'm gonna encounter the moon out here at this little first blue circle. Then that yellow mark is how close I'll get to the moon. I'll get about 230,000 meters away. Then I'll follow that orange line and I'll escape the moon's gravity. And then I'll start following this blue orbit, which is kind of an inclined orbit now. So we weren't perfectly equatorial when we got to the moon, and it kind of threw us off a little bit. So when we come back, that difference is going to be greatly exaggerated. But we should be in pretty good shape for getting back to Kerbin. Still got about 83 units of fuel left, so that should be hopefully enough Delta V to get us back into the atmosphere. So I'm going to go ahead and make sure I turn off SAS so I don't waste any battery charge. And we're going to see if we can find the moon out here. There it is. And we're going to time accelerate, because this is going to take a long time to get there. You can actually see it's actually going to take a day and 4 hours and 10 minutes. And if you didn't know this already, a day on Kerbin is only 6 hours. So that's taken us about a total of 10 hours to get all the way out there to the Mun if we were to wait a normal time, which is why they make time acceleration in the game. Very useful feature, but a little easy to get carried away with the time acceleration. So you don't go more than like 1,000 because bad things can happen. You can miss your targets, you miss your rendezvous that you want to get to. All right, now what's interesting here, I'll slow it down, is notice how far away the moon is right now, and I'm almost to the point where I'm supposed to be encountering the moon's gravity, right? Well, as I get farther away from Kerbin, I'm slowing down by a huge amount, because it's kind of like throwing a ball up in the air. When the ball gets to its highest point in the air, it comes to a stop briefly before it falls back down to the Earth. And the same kind of thing is happening here with my rocket. As I'm getting farther and farther away from Kerbin, I'm slowing down, and the Mun is keeping a pretty constant velocity of 500 meters per second, so that by the time I get all the way out here, the Mun's going to be really close by, and I'm going to be captured by its orbit. Its gravity. I'm going to be in orbit around the Mun, because I'm going to be captured by its gravity. So here we go. Slowly cruising, 200 meters per second. And at the apoapsis, coincidentally, another kind of fact about orbital mechanics here, that will be the slowest point in my orbit. Periapsis will be the fastest point because I'm falling all the way back down towards the ground. But remember, when you're in orbit, you miss the ground. So if you have a big difference in your periapsis and your apoapsis, you're going to have a huge difference in your speed. All right, let's time accelerate some more. Let's get on out here. And as we fall back towards Kerbin, now we're going to be captured by the Mun's gravity. And here we go. So if I wanted to get in orbit around the Mun, what I would need to do now is set up a maneuver at my Mun periapsis and simply slow down. And you can see if I slow down by 181 meters per second, then I'm going to be in orbit around the Mun. But I don't want to quite do that just yet. In fact, I'm going to let some people try to figure this out here on their own for the Great Space Race. See if you can figure out how to build your lander and how to get into orbit there on your own. But yeah, this will cruise us right on by the Mun. I'm going to get a little bit closer here. I'm going to wait till I get to that periapsis. Try to get some science points from the Science Junior module. So there we go. And let's look at the view of the Mun now. You can see sunset on the Mun. Look at those beautiful craters. So nice. All right, gonna do a crew report. Get some good science points there. Observe the materials bay. It's worth a whopping 50 science points, so that's good. And I'm gonna do an EVA with Jebediah. We're gonna do a little EVA report here. And we're gonna get that. And we're gonna take the data and we're gonna store the data. And we're gonna get back on board. And there we go. We have now flown by the Mun. We're gonna keep going on this path, and at this point out here, we're gonna escape the Mun's gravity, and then we'll be back in orbit around Kerbin. And this is why they call it a free return trajectory. If you can have different trajectories, but if you don't plan it right, you can escape the Mun's gravity and just kind of go sailing off into the solar system. You get a little gravity assist from the Mun, and it speeds you up, and then you're no longer anywhere near orbiting Kerbin. So they call it a free return trajectory because you encounter the body, and then after you're done encountering the body, you just sort of continue to orbit the previous body you were around. Fun fact for you there. That's the kind of trajectory they used on the Apollo missions to get the astronauts back, because it's, you know, it's the most fuel efficient way to go. You don't want to have to waste fuel by trying to get back into orbit around the planet you're coming from. All right, so now I'm back into orbit around Kerbin. Bye-bye, Mun. Nice to see you. We'll come back again soon. And now I need to get back into the atmosphere, and this can be the tricky part. Okay, so turns out that the best place to change your orbit is the periapsis, because you're going the fastest, and it has to do with the kinetic energy formula. It's called the Oberth effect. You'll get the greatest amount of orbital change, I guess is the way it works, by burning at the periapsis. I'm concerned about fuel though. I want to make sure that I can get back into the atmosphere. So I'm actually going to, okay, so here's the other thing too, is that my apoapsis is so high, if I were to try to burn at the periapsis, how long would it take me to get back? How much delta V would it take? It would take me quite a bit of delta V. I would need to burn for quite a few number of seconds. 44 seconds with a burn time. I don't think I have that, and that's still not going to get me back into the atmosphere. So I don't think that plan is going to work. I'm going to have to go with burning here, slowing down at this point, and letting that apoapsis just barely dip down into the atmosphere. I'm going to need to try to save some fuel to slow down once I'm there too, because if I'm going too fast here when I re-enter, which I will be going pretty fast, then it could be bad for business. So I just want to barely kind of skip across the atmosphere the first time, I think. Haven't had too much experience with re-entering with the new aerodynamics, so I'm just going to kind of barely go across there. 69,000. Or should we just go for it? Should we just put it down into the 40,000 range? Why don't we just do it? Let's just go. 50,000. 36,000. That should be good. Let's aim for 36,000. And notice, to get that out here, I've only got to burn for 2 seconds. So that's kind of cool. Gonna point to my maneuver node, which is still an hour away, so I don't really need to do that yet. I'll keep it there. Yeah. And I'll just turn off the SAS. I want to drift a little bit. Let's get a little closer here. Let the time run down. And I'll readjust when I need to, when I'm getting close. 20, 13 minutes. 10, 9, 8, 7, 6, 5, 4, 3, 2, 1 minute. Alright, so let's get our guy pointed at the maneuver node here. Pointed retrograde. Do I have caps lock turned on? Yes, I do. Okay, just checking. And right about there is good. I need to change my speed by 36 meters per second. And that's going to happen in about 30 seconds. So let's see how good I can get this here, because there's a very little there's a very small margin of error here. If I go bring that periapsis down too low, I'm going to burn up in the atmosphere. If I keep it too high, I'll skip right across the atmosphere and also probably burn up. So that wouldn't be good. All right, 2 second burn, so I need to burn at T-1. I'll go ahead and start it a little early. And oh, yep. Okay, so now I need to go prograde. I need to speed it up a little bit. I need to raise the apoapsis, or raise the periapsis, because I am too low. Oh, let's not use that. I used up a lot of electricity doing that way. When you turn on the SAS, as your pilot levels up, you've got these other little maneuver node options here, like hold prograde and hold retrograde, but those use up a lot more electricity. let's slowly bring it up. Let's go. Yeah, 39,000. That's good. There we go. Okay, so now I've got my good apoapsis there, and I've got a ton of fuel left. So before I get there, I'm actually going to use a lot of that fuel to try to slow down, try to adjust my periapsis even more, so that I don't go too fast in the atmosphere and burn up. Let's see how this goes. Alright, let's turn off the SAS so I don't use up my battery. Need that for holding retrograde as I'm re-entering so I don't explode. And let's speed up time. There we go. Closing in. This is the moment of truth. How fast am I going to be going here? Alright, 100 times. So 2,200 meters per second. That's really fast. Let's get pointed retrograde here. See if we can slow down some more. Oh man, yeah. Going really fast here. 3,000 meters per second. So when I get under 100,000, yeah, I'm going to try to start slowing down now because I am booking it through here. This is really moving fast. And I'm really worried about blowing up in the atmosphere. So let's go ahead and slow down as much as we can. Hopefully that doesn't lower my apoapsis too much. Oh man, really killing that speed. Oh. Alright, I don't want to lower it any more than that. I'm going to wait until I'm actually in the atmosphere to try to slow down there. And a little bit of a crazy spin here. Let's find that point. Let's find the retrograde. Alright, so I'm in the atmosphere. I'll try to use that to slow down some. Try to use up some fuel. Let's see what happens when we separate there. There we go. Alright, can deal with that. And let's see how the heat shield does. See how it holds up. Oh yeah, you can see we're definitely not going back into space today. I think we're in good shape. That heat shield's gonna hold up pretty well. Get into some pretty dense atmosphere now. A lot of air resistance, blowing off all that heat, thousands of degrees Celsius, just being funneled off of the ship. Jebediah, the giant fireball frog. Will he make it down to the ground? Yeah, this has worked out pretty well. I had tons of fuel left. Probably could have even gotten into orbit around the Mun and still had enough to get back. That would have been pretty sweet. I think I'm going to go for that next time. I think we can use the exact same ship. Oh, no, don't go too far. Don't go too far off of retrograde there. In fact, should we just hold retrograde? Yeah, let's see how holding retrograde. No, that's not working. Okay. Keep it there. No, keep it. And I think we're good. I think we're good. Yep. We're through the worst of it. And looks like we're going to have a nice gentle landing in the water. Don't have to worry about any altitude issues with the parachute. Can turn off SAS now. It should be a nice gentle cruise all the way down to the water. And there you go. Thanks for tuning back in. If you want to stick around, see how many science points I get on this one, go for it. But otherwise, you can go experiment with your own rockets now and see if you can get this done. There goes my parachute. Don't want to remember not to time accelerate through the opening of the parachute. Bad things can happen with the physics when you're time accelerating. Oh, look at that beautiful night sky. So I gently cruise on down. I wonder what would have happened if I hadn't slowed down. I wonder if I would have been okay. I think I would. I only used 7 units on the heat shield, so I think it would have been good. Alright, there we go. Let's recover the vessel. And got a whopping 88 science points on that one, so it's going to be good enough to unlock some more technology nodes. And got some parts back, got $2,000 back from parts. Jebediah leveled up. Let's recover these little pieces of debris from the launch. Alright, so 104 science, $200,000. The next upgrade that you really need to consider is the building assembly, because right now that rocket that I launched was really pushing the limit on the number of parts, the maximum number of parts. If you upgrade it, you can make a lot more parts to your rocket, let's just say. So up to 255 parts are supported if you upgrade to level 2 for your vehicle construction. So that's actually going to be the next thing I'm going to do. I'm going to go ahead and upgrade my building so I can build bigger rockets. That used a lot of my funds. I'm down to 72,000. So I've got to pick my next contracts carefully. Also, let's see, technology-wise, I've got a lot of choices here. Fuel systems, advanced construction. But as I do more complicated missions that are going to require me to spend longer amounts of time in space, I really need to consider getting these photovoltaic panels next. So this is actually going to be the next node that I unlock for science, because it's got this, the basic solar panels on there. It's got a bigger rechargeable battery. It's got a probe core that it can allow me to fly things without having an actual crew attached to them. So those are all good things to have as we start progressing towards a moon landing. You know, if we want to model like the real missions to the moon did, we would send next a satellite to orbit the moon. We would then send an unmanned lander to see if we can land an unmanned probe, see if we can land something without killing anyone. And then we would finally send an actual manned mission to the moon, and hopefully by then we could send 3 people at once and not just have one little guy. But it is a lot easier to land somebody on the moon if you've just got the one-man crew pod. Alright, well that's all for this episode. Tune in next time. Next episode we'll be probably putting some satellites up. We might be doing some a little bit of rescue missions, so you can learn how to rendezvous with things in orbit. And we'll continue our little Apollo series missions to the moon and see if we can land stuff on the moon. Thanks, and don't forget to click like and subscribe.